All the discussions done? Done? Go ahead, sir. Okay. Is it okay? Further, I can give quiz for 10 marks. Please give me as a 10 marks discussion. Is it fine? So let me give you so between this, I'll get you discussion quiz. Y'all really give petition of state discussion for. So that I'm free of it, we are free of it. Right? Okay, come back. So there will be a quiz before your first internal any day. I want to get well. So any day I'll give a quiz and I'm having a very to teach. Done. Yeah. I'm sure. I am actually creating on this lecture. It actually many classes happening. So, by before your first picture. That was a March, this is a discussion of the Fine. Okay, so let us come back and start to explain what first. As we discussed, then the example is now. So after that, that is a completion of your module 1. Now we are moving on to module 2, the chapter 1, relational database and the concepts we are going to see. So let us see what is meant by relational database. So currently, whatever the database you are working on is relational database system. So how it is done, what is meant by relational database, what are the characteristics of the relational database, and some of the key constraints we will be seeing those things. So it has been already started for you in the lab. So this is your lab part. What do you mean by relational database? Because talking about very all those are nothing but a relational database. Right. So all the first module, what you learn is nothing but a theory. Introduction to database. What do you mean by databases? Some of the ER diagrams, some of the history of database management system. From here onwards, your action topic starts related to your lab or your practical work. I'm talking about practical work. Whenever you go into any companies, the work in database, actually it starts from this chapter. Because I'm telling you frankly, anywhere you go, if you're working as a DBMS, you have to carry that textbook and go. Because once you enter into your company, no one is going to teach you. You have to self-learn. So how do you self-learn? The textbook, this one textbook is one of the very good books. It is one of the book where you are going to self-learn and you are comfortable to understand it. Frankly, you are studying this third year. If you go there, you will forget. That's related. That's only something that you will be forgetting what you are studying. So once you enter into your company, it starts from this chapter. From here, your actual practical life starts. Why I'm telling because I have experienced it. I have taken the textbook from the library. I have studied it from this chapter only. That's the reason I'm giving you my experience. So I'm just telling you from where you have to start. But try to understand. It's very easy. So let us continue. So let us see what we mean by the history of relational database model. So we have seen it in the history of database. Who starts with database queries, SQL queries? Yes, so some of the first, it has been introduced by Ted Cod at 1970 and is going to use the concept of mathematical concept of sets. That means sets and relations is using this concept. It tries to derive a basis. Next, the first commercial, these are the last theories. which I have already spoken in the history of database systems. So one of the commercial relational database system first introduced was Oracle. Then after that, Oracle DBMS, database management system. After that, SQL, data structures system by IBM, it was been done. So this is being introduced by Ted Core, initially introduced in Oracle. Then after that, Oracle or IBM also took over and they introduced a database management system. The name was SQL. Next is the current DBMS which we are working is Relational Database Management System. We are going to learn about that only right now. Relational Database Management System and some of the commercials which are there is from Microsoft, SQL Server and Access. That is the current relational database which is there. There are also DB2 and Informix by IBM. So the language which we use for RDBMS is SQL query language. We have seen these are some of the history of relational database system. We have seen all this, so I'm not going to take on explanation. So what is the basic part of the application? So let us move directly to the terminologies. You should know some of the terminologies. What do you mean by relational? So what do you mean by a relational model? It represents nothing but the data as a collection of tables. So we know what do you mean by tables? Yes. So the other formal name for tables is nothing but relational. Okay. So we have seen informal names, tables, rows, columns. Yes, data. But the formal name, what do you mean for tables is nothing a collection of data. You call it as the relational. And relational name. So for example, what is the relational name here? For an example here, student. This is the formal name. Relational we call it as. Informal name we call it as the, what is the table name we call? Yes, the table name is student. So table name and relational name is nothing but collection of some data. Next, each row, whatever the data you have entered, you call it as the tuples. Next, and what are all these called? Attributes. You know by now. So this lesson deals with all those things only. Nothing extra. You know you have already learned. So this scientific, you had a black, you have already learned it. So this lesson deals with that. The relational database, how did your main table came, the rows came, tuples came, and all those things. Correct, right? Fine. Okay. Next. So as the terminology says, so this the current come Bantok. What is the discussion? Right? So all these things, we call these as the column headers are called as the attributes. And the data which are inserted from one, we call it as the tuples. And the data collection of data, we call it as the relational name. See, these are some of the terminologies. So what do you mean by the domain? Next terminology is domain. So domain is nothing but it's an atomic value along for an attribute. So what do you mean by an atomic? What do you mean by atomic? Something which you cannot divide, it is not divisible. That means you cannot divide anything and again. So that is mean by atomic value. So it's an atomic value of an attribute. Yesterday's example, I told about which example is about the party events representative. Yes, in that there was an attribute, remember party. So what are the values you can enter for the party attribute? What was the values you can enter? Independent, democratic, then republican. So these are the maximum number of data or the constraint they are giving that you can enter for that particular attribute. Such type we call as and such type of values which are entering inside an attribute we call it as a domain. Fine. So what do you mean by a domain is atomic value. So you cannot divide it further. So you are telling this type name. Name is one of the attributes. So I am telling the name which are there, it should be of a type character. So I cannot divide it further. So I am not telling it can be of the name number also. It should be of a type character. So next age. If I am taking age as an attribute, it should be of some integer number between, in an example I have taken between 20 and 70. So I am fixing my attribute to that particular value. So whatever the value for that particular age attribute there, it should be a type integer between 20 to 70. So you cannot put some characters inside that particular age attribute. So that is what we call as a domain. So you are fixing the what values are entering inside the attribute. Yesterday we saw an example, one more example we saw. So vote for. So pass dot pay, one more attribute for the pass dot pay. So what was the domain which is prescribed in that question? Yes or no? Other than that, you cannot put anything else. That is called as domain. What values are entering inside the attribute? Fine. Next, let us see what you mean by the relational schema. So this is nothing but it is describing the relationship. So entire relationship is being described. That means the relation name along that relational name, whatever the attributes is going to come. So that is the description of that particular relation. We call it as the relational schema. How do you represent it? Describe the relationship made up of relational name R and the list of attributes A1, A2, A3 up to N. So how do you represent it? If I'm representing it, student, what do you mean by what is the student? Relational name. Fine. So these are the attributes. This entire thing is called as the relation schema. So, which are my attributes? Name, roll number, age, phone number, grade. Fine. And next one is degree of relationship. Degree of relationship is nothing but how many attributes are there in that particular relational name. In this example, what is the degree of this relation? 6. That's it. Understood? So, how you can represent this relational schema? You can represent it in two ways. One is student, name, age, roll number, age, address, phone number. Directly you can represent. Otherwise, one more name is student, name, colon, with that. What is this? Data type we call it as, otherwise we call it as the domain. So, which type of data you have to enter? So, here name should be of the type string, roll number should be of the type integer, age of the type integer, address of the type string, phone number of the type string, grade of the type real number. So that is the domain. Along with the domain, or we also call one more name for that. What is the one more name for that? data type. That data type we can specify that entire thing. There are two ways of writing the relational schema. One is this way, one is along with the data type. So when you are entering right now in your lab, how do you enter it? You enter it with the data type, no? You tell some name of the type, character, then some names of the type integer, along with that if it is a prime number, put it as the prime number. So you enter it in this particular way. So it's not mandatory, they have to enter in those way only. You can enter it in this particular way also. Just pass the name. Or you can just pass the attribute. But what happens at times internally when you are storing, what happens is everything is going to be of the type none. Yes, whatever is going to be of the type, it is not specified. So you do not know what type of data you have to enter inside that. So it's a good practice to by the creating your relational table or relational name is a good practice to have the domain or the data. Next terminology is cardinality. Cardinality is nothing but total number of tuples that has been present in the relation. So in this particular example, how many tuples are there? 3 tuples. So that we call it as the cardinality. See, this is nothing but some of the terminologies which you should know. So we have seen relational name, degree of relation. Next is then domain. Next is tuples, attribute, then relational schema. So next terminology which we are learning is cardinality. It is nothing but the how many tuples are there in a particular relation. That is called as the cardinality. So in this particular example, there are 3 data which are there, or we call it as the cardinality. Next is relational database schema. So what do you mean by relational database schema is nothing but it is a set of relational schema and set of integrity constraints. So when I'm talking about relational schema, what do you mean by relational schema? The set of the name is equal to that particular that table, and then along with that the data, the entire thing we call it as the relational schema. So here in this student, which what is roll number, name and age, those are the attributes. Along with that, all those together we call it as the relational database schema. Fine. Next is relational state. This we have seen in the previous chapter. Remember? Or no, forgot? We have seen about the relational state. What do you mean by relational state? At present, your relational, whatever relational is there, I mean, when I'm talking relational is nothing but the table. At present, what is the state of your table? Fine. What is the state of the table? What is the cardinality? 3. So, what is the present state? That is called as nothing but the relational state. Fine. Set of tuples at a given time. What do you mean by tuples? Nothing but each row or data which are there. At present, what is the state of your relational or your table is called as the relational state. Understood? Or sleeping, morning. Fine. So some of the definition summaries, formal how we call it, informal how we can call it. So for an informal name is table and the formal name for table is relation. Fine. Next is column header. Formal name is attribute. Next is all possible column values. You call it as the domain. What do you mean by that? What do you mean by all possible common values? Whatever the attributes are there, what type of values you can enter, such things we call it as the domain. So if there is an age attribute, you can enter only integer type of value. So such we call it as the domain. Fine. Next is row. Row, the formal name is tuple, table definition, you call it as the schema of relation. And its populated data is nothing but the state of the relation. That means how much tuples are in that at that correct time in that particular table. You call it as the state of. This is one of the simple summary for formal terms and informal terms. Let us move on next to the characteristics of the relation. So here, what are the characteristics of a relation? The first characteristics of a relational database or the table is ordering of tuples with a relation. So what do you mean by ordering of tuples with a relation? So you have a relation, you have a table, and you have some order. So what is in my example? Student is my table name, and these are the attributes: roll number, name, and age. So whenever you are entering the data, you have entered the data. It's not necessary that it should be in a proper order. So it's not necessary that it should be in an ascending order or descending order. Any way you can enter your data. So that is called one of the characteristics of a relationship. That is, a relation is a set of tuples. Fine. Tuples in a relation need not have any particular order. Whatever the data you are entering inside your table need not be of a particular order. That means it did not be of an ascending order, not be of a descending order. You can enter data in any order. If you want to implicitly make it clear, ascending or descending, what is here you have order. By then, you say if you want to get descending order, everything you have to do. So what are the telling is whatever the data is initially there in your database, you can order or you can insert data in any order. It's not mandatory that it should be in some order. Any order can be entered or it can be stored. So here, in example, see here, the first data is 1, 2, 3, Harry, Ben, and Kathy. So in the next, it can be like this also, 2, 1, 3. In any order, you can enter the data. Fine, that is the first characteristics of the relations. Next characteristics is ordering of values inside a tuple or within a tuple. So when I'm talking about values, what do you mean by values? Whatever the data you are trying to put inside the, what do you mean by a tuple? Rows. Yes. So whatever the data you are trying to put, no, it not be of some order. It should be of some order. If you do not want to be in some order, what you have to do also we have to see. So let us see the theory part first. And tuple in an ordered list of n values. So ordering of values is in a tuple is important. So whatever you have given the structure of your database, you have student, roll number, age, name, and age. This is what you have created. Fine. Inside the schema, inside the table, what is the table? Student is a table, and attributes are roll number, age, and name. Roll number, name, and age. This is the way. So what values you are putting inside that particular data or that particular relation, it should be of that particular order. That is one point. So it should be of an ordered list. When I'm talking of values, see there are two things. See here, in the previous one, you have name, age, and roll number, name, and age. So in the previous characteristics, what data was there, it is not necessary to be of an order. Here, you have created a schema, student schema. Fine, relation you have created. Inside that, you have told my first row is, column header is roll number, next is name, next is age. So what you're entering the data, no, it should be of an ordered list. So first you should enter roll number, then you need to enter the name, then you need to enter the age. So that is one thing. So how are you going to do it? How do you do it? Guys, how do you do it? Insert values, then you give this. Let's open the insert values from along. You give the name, give the attributes name, and then the data type. Yes, and you give it in the order way. So if you do not want to give it in order way, what you have to do? So there are two things in this characteristics ordering of value within the tuple. So two ways you can enter. One is in the order list. Very important to enter in the order list. That is how you have created your table. That only you have to enter the data. Next one is if you do not want to enter in the ordered list, how you can enter. So how you can enter this set of attributes along with the value pair. So how you can enter it if you do not want to enter in the ordered list, you can enter it with the set of attributes along with the pair. Then the ordering of attributes is not important. So you can enter in two ways. One is in the ordered list, where ordering is important. If you do not want to enter in the ordered list, so you have to enter in this way. That is, T is nothing but the tuple for that particular this roll number, comma, 2. You are entering the value here. So roll number, then 2, then name, then age, 22. This is one way you can enter. So can you see the next example? How are you entering? First you are entering name, then you are entering the age, then you are entering the roll number. So this is one more way of entering the data into the data schema or the relationship. Okay, entering your relationship. So entering the data into your relation. This is one more way. So most of the time we practice which type of way? How are you practicing in the lab? This way or the first way? Most of the time, everyone, most of the time, we practice only the ordered list of entering the data. Fine. But there is also how are you entering the data in order unordered list also. This is one more way where you can enter along with the attributes and values. Yeah. That time it's not necessary to go in the ordered list. But this is mandatory. Along with that, you have to have the attribute and then the values. That time it's not necessary to follow the order. In an unordered way, you can. So most of the time we enter in the first possible way only. That is in the orderly way. This is one more characteristics of relation. That is of a table. First one is what is the first? What is the first one? Ordering of tuples within the relation. Next one is ordering of values within the tuple. Any doubt here? All are simply enjoy these guys. I'm telling story over here. Fine. Next one is next characteristics. See, there are four characteristics. First two we finish. We'll see the next one. Next one is values and nulls in a tuple. So we have seen this. So what type of values you can put inside this particular relation? So the next characteristics is values and nulls in a tuple. So what type of values you can put? We have seen composite values. We have seen multi-value. Yes, but when you're actually designing or actually putting values inside a table in relational database, what happens is there is no concept of composite values. There is no concept of multi-value. Fine, those are just for the ER value. Okay, when you are creating a database, when you are adding some values inside a relation or a table, there is no concept of compared talking. Listen properly. There is no what do you mean by composite value? Attribute. It can be further divided. So you have a name, first name, last name, yes, second name or third name. Yes, this is nothing but But what happens is when you are designing it, you are each value in the tuple is going to be of a type atomic. That means it cannot be further divided. So when you're creating a relation, what happens here in the above example, you have student, roll number, name, address. But usually you will not have only one address. You might have address 1, address 2, even the place. Yes. What you can do is, instead of having address, most of the time we'll be having this type, all these composite. Address can be three things, right? You need to have the pin code, you need to have the state, all those things should be there, which is the composite value and an attribute. So you're not going to, in the diagram, you can do a circle and point it. You can have state, pin code. But when you're doing it practically, you cannot do it. So what happens is each value what you are entering inside the attribute tuples, it should be of untapped determinant. It should not be able divisible. Okay. So what is happening? You are dividing this entire attribute into a separate single attribute. So that address has been divided into city, state, pin code. That is how you enter the tuple values. So that is one characteristic. There is no concept of, you should know what do you mean by composite attribute, what do you mean by multi-value attribute. But then practically when you see, you are actually doing it as a separate attribute only. Understood? When you are practically implementing it, you are actually storing the value as a separate attributes only. In this above example, you have address. In address, you have Bangalore, then you have Karnataka. Bangalore is, what is a Bangalore? It's a state, district, city, what is it? And what city? What is Karnataka? Fine. So, what will happen is, you have a city. So, what happens is, instead of giving all the values, please for my class. Fine. Why late? Huh? Why late? ಯಾಕಪ್ಪ ಲೇಟ್ ಗೇಟ್ ಬಿಟ್ಟಿಲ್ವಾ ನಾನು ಅಟೆಂಡೆನ್ಸ್ ಕೊಡಲ್ಲ ಕಳ್ಸಿದ್ದೇನೆ ಅಷ್ಟೇ I want to attendance, you can come and sit, it's your wish. Fine. Okay, so this entire thing of address, which is a composite attribute, is been divided into an atomic value has city, state and pin code. Same thing goes for your multi-value. What do you mean by multi-value attribute? It is a combination of composite attribute and composite attribute and multi-value. Same thing goes for your complex attribute. The combination of multi-value and composite. Even multi-value is also things that you are going to have. You are going to have a different atomic value. Guys, enough. So next is, there are still 10 minutes to start. They don't do that thing. Otherwise, I'll not do whole class in attendance. Don't want that. I know when to get attendance. So next one is nulls. So nulls we have already explained in the previous class. What do you mean by nulls? Either you do not know what type of data, what is the data that is available, or we might not be knowing if I do unknown of that. Yeah. Guys, decide. Fine. So for an example here, you have these attributes. In the data of Harry, you don't know the mobile number. So you are unknown about it. So you can save it as none. So this is one more characteristic of relation or the table. Next, the last one is interpretation of a relationship. How that particular table you are trying to read. What do you mean by a relationship? Exactly what a table. How are you reading that particular table? So whatever the data you are trying to add, so you have this. This is your relation. In that relation, you have roll number, name, age, and mobile. So when you just see it, can you understand it? Yes. When you just read student, name, roll number, mobile number. When you understand it is some people or it is some relation belonging to a people or student, where you have to add the name, roll number, mobile number of a particular state, of a particular student. So that is nothing but interpretation of a relation. You are trying to answer what type of data you are trying to add inside that particular relation. Fine. Next is each couple can be interpreted as a fact. That means once you add the data, you can read it very easily. That's it. So here I have added for a student table name, pen has been added. So once I know the data when I know his age, 22, his mobile number. So each couple, once you add the data inside a table or a relation, you can read it very easily or you come to know about the details of a particular. So this is the last characteristic of a fine. So done. So we'll see the next topic in the next class. Any doubt till here? Inayat? Today 28. Inayat? Yashas? Jagadabi? Jay? Jay? Jayant? Janvi? Jitu? Priya? Akanksha? Rekha? Kailash? Kalesh? Karthik? Kirtan? Kirtana J? Kirtana S? Kirti? Kiran? Absent no? Came late. Kishan? Kritika? Kunal? Where is Kunal? Girish? Kushal? Lakshmi? Ravanya? Likit? Likita? Likita R? Venkat? Yashashwini? Yashashwini? Akshay? Manoj? Manoj S? Meghana? Meghana R? Mohammed Salim? Adnan? Mohit? Where is Mohit? Monica? Muskan? Muskan Patel? Jay? Nagaratna? Guys? Nagashri? Namita Singh? Nandita? Nasim? Nazir? Navnita? Naveen? Neelam? Neha? Neha? Nikhil? Neerav? Nikhil? Nisarga? Nishant? Pallavi? Lakshman? Pawan? Pooja? Pragna? Monica? Naveen? Navya? Naveshri M? Naveshri S? Nitish? Darshan? That guy, no? When the classes are there, he'll not come. When there are no classes, he'll be present. Who are my mentees under whom I'm mentoring? Send your certificates. Still, I have not got from some people. Does it not send the certificate? Internship. When you send next year, then hey, this is your job, okay, everyone. Remind me to take photos, please. I'll not remember it.